So we are going to start with creating confidence intervals today. This is going to help us estimate a population proportion. And just to recall that in this class we use the letter P to show that we have a population proportion. Although you also might see it as pi in other classes. So we're going to start by talking about the conditions necessary for constructing a confidence interval for proportions. And actually, I have a feeling most of these, or all of these, should be familiar to you. So the first condition is that our data come from a random sample. Now, if they're not a random sample, there is still something that you can override it with. You can also have the assumption of independence. And so hopefully this seems familiar from a previous chapter. The second condition is the 10% condition. And the third condition is the success failure, which you also might see called the large counts condition. And in this one, we want both our n times p hat, not n times p, and our n times 1 minus p hat to be both greater than or equal to 10. So let's do an example. So we have a woman named Mrs. Quinn who has several thousand pennies. She wants to construct a confidence interval for the proportion P of pennies that are more than 10 years old. This is what we're going to be looking for. We're going to be looking for the proportion that are more than 10 years old. So her sample has 57 pennies that were more than 10 years old and 45 that were at most 10 years old. First thing we want to do is check the conditions. However, before we check the conditions, and this is going to be true for any confidence interval, we always need to figure out a few things. We need to figure out what our n is, our sample size, and we need to figure out our p hat. So that is the first thing that we must do. You'll notice that two of our conditions actually involve a few of these things. So my n is going to be my total sample size. So be careful on this. It's not 57, it's not 45. It's actually going to be the sum of those, which is going to be 102. My p hat is going to be the sample proportion of pennies that are more than 10 years old. We know that that's what we're looking for because that's what she's trying to estimate. So if you look at the more than 10 years old, 45 of them were, 57 of them were more than 10. So our sample proportion is going to be 57 over 102, which is going to give us about 0.559. So before you do anything else, make sure that you get the right sample size, make sure you get the right sample proportion. You got to do that first. Sometimes they'll actually give you this stuff, but this one, they didn't, but that doesn't mean that you can't do it. Just make sure that you get it on your own. Okay, so let's check our conditions. So the first condition is a random sample. This actually doesn't tell us that it's a random sample. However, we are going to have to assume that that the pennies, since there's several thousand of them, they're mixed up. So we can assume that the pennies are independent. It's a reasonable assumption here. The next thing that we're going to do is our 10% condition, and they actually tell us the population size, which is several thousand. So our sample size of 102 is less than 10% of all pennies. Okay, the last thing is our success failure condition. And in this case, we are going to use NP hat. What you're going to find is, this is a nice little trick, by the way. You actually are going to get 57, which you might notice is what they actually started with. The N1 minus P hat is similar idea. You are actually going to get the 45, which is what they gave you for the failure. So the success in this case was the 57 pennies. The failure was the 45. And both of these are at least 10. So our conditions are satisfied. And actually, usually this is the point where I say, my conditions are satisfied. I can use A, and I name the interval. So I'm going to say, I'm sorry if you ran out of room, because I ran out of room too. So we are going to use, this is called a one proportion Z interval. And I want you to start getting in the habit of, after you check your conditions, to say what you are going to actually do, to tell what the name of the interval is, or what the name in the future we're going to do what's called a test. So in this case, it's a one proportion Z interval. You might remember seeing the letter Z in Z-scores. They're closely related. So this is going to help us out. We're going to be using the Z interval for proportions. Okay, next thing we're going to do is I'm going to give you the formula for standard error and discuss a few things about what's called a critical value. So the standard error, it might remind you of the standard deviation. So the standard error is actually just going to be the standard deviation from a sample. And in this case, my standard error has a formula, and I write it usually as SE, of the square root of P hat times 1 minus P hat over N. I'm hoping this looks somewhat familiar. And then I also am going to have a value called the critical value. And we denote the critical value as a Z star. And this is going to be based on what's called your confidence level, which we learned about in the last section. Okay, so I'm going to skip example number 5 for now, and we're just going to go straight into actually finding a confidence interval. So before we do that, I'm going to give you the formula for a one sample Z interval. Our formula is going to be P hat, our sample proportion, plus or minus my critical value Z starred times my standard error, which is P hat times 1 minus P hat all over N. So just to make sure that you know a few of these terms, this P hat is going to be my point estimate. Out of the things to remember in this is probably the least important, but it's a nice thing to remember if you can. The Z star, remember, is my critical value. This thing right here is my standard error. And actually, this entire part that includes the critical value and the standard error is called my margin of error. So you should be very well aware of what the margin of error is and what the standard error is. So let's go ahead and do an example. So our local newspaper polls a random sample of 330 voters. They find 144 who say they will vote yes on the upcoming school budget. We're going to construct and interpret a 95% confidence interval of the proportion of voters who vote yes. Okay, so I gave you a little step-by-step process. Actually, before we even do the steps, the first thing that I think it's always a good idea to do is to identify a few things. You're going to want to identify your n, you're going to want to identify your p hat, and you're also going to want to identify your z star, your critical value. So my n is my sample size, which in this case is 330. It's the total number of people in the poll. The p hat is the, in this case, we are going to be looking for the proportion of voters who vote yes. I'm actually going to write down this as defining my parameter. I'm going to define my parameter as p. Notice how I didn't put a hat because this is a parameter. The p is going to be the proportion of voters who said yes. And we're going to be using 95% confidence, which they specifically told you up there. If they do not tell you a confidence level, sometimes that happens. I would say rule of thumb is to use 95, but make sure you say that you're going to use 95. So since our parameter is the proportion who vote yes in the population, the p hat is going to be the proportion who vote yes in the sample. So that's going to be 144 over 330, which as a decimal is going to be approximately 0.436. So in this case, I'm going to show you ways to find the z star later on. Actually, for 95% confidence, it's always going to be 1.96. And if you want, you can just remember that because you'll probably remember it because you're going to use it so often. But I will show you in class how you can find that. Okay, so then the next step is to identify what method you're going to use. This is important. This is what I mentioned before, where you name your, you actually are going to give a name to your interval. So this is we are going to use a one proportion z interval. And one hint is that everything in this section is a one proportion z interval. And we're also going to check our conditions. So they specifically tell us this is a random sample. We're going to assume that 330 is less than 10% of all voters. This is a pretty reasonable assumption here. And the last thing is our success failure. So you'll find NP is going to be 144, or NP hat, sorry. And 1 minus P hat is going to be 186. And these are both definitely greater than or equal to 10. So all conditions are satisfied. Okay, so now that we know our conditions are met, we are going to use our formula and we're going to perform calculations. So our formula, remember, is P hat plus or minus the critical value times the standard error. And here, you just need to plug in your numbers. So we are going to get approximately 0.436 plus or minus 0.0535. So just a reminder, this part right here is our margin of error. I just wrote it as ME, but that's margin of error. So this is approximately a 5% margin of error. You're going to see stuff like that. I'm hoping that as you take this class, you'll see more and more stuff if you read the news article or something. So if you see a margin of error of 5%, this is actually what they're doing. So we actually are going to write our answer we're going to take it one step further to write our answer. We are going to split this into two values. We're going to split it into 0.3436 minus 0.0535 and 0.436 plus 0.0535. And that's going to give us, our lower value is about 0.382. Our higher value is about 0.49. So it's going to be about 0.382 and 0.49. What this is telling us is that there's a strong likelihood that the actual percent of voters in this county is between about 38% and 49%. So that's what this is telling us. So we do need to write an interpretation of this. And the AP statistics test has a very, they don't want you to be creative about the interpretation. They want you to say something along these lines. So you're going to say something along the lines about, we are 95% confident. So you're going to always do whatever confidence level they give you. And then the next thing is going to be the parameter, the proportion of voters who will say yes. So this is going to be right here is going to be whatever the parameter is that you defined earlier on. And then you're going to say is between, and then it's going to be whatever you had in your confidence interval, 0.382 and 0.49. So to be honest, if you're on the AP test, this is pretty much exactly what they want. They want you to not be creative at all. They want you just to follow this format. I personally, it's more important for me that you understand what we're talking about. We're very confident that our proportion who are going to say yes is between these two values. That's what I want you to get from this.